Dear friends, welcome to another video tutorial. Today we're going to learn how to use an RGB LED with Arduino. There is a lot to cover, so let's get started. Hey guys, I am Nick and welcome to Educates TV, a channel that is all about do-it-yourself electronics projects with Arduino, Raspberry Pi, ESP8266 and other popular boards. In this video we are going to learn how to use an RGB LED with Arduino, a very interesting type of LED. As you can see, I have connected this LED to an Arduino Uno and every second it changes its color. That's very handy because we can use only one LED in our projects and produce many colors. But what is an RGB LED? An RGB LED is a light emitting diode which can display any color we want. It consists of three discrete LEDs, a red, a green and a blue LED, housed in a single package. So by combining these three colors we can create any color. As you can see, the RGB LED has 4 pins. So far the LEDs we were using only had 2 pins. The pins are used in order to control the color of the LED. The longest pin is either the anode or the cathode, depending on the type of the RGB LED. The LED I have bought is a common cathode LED, so the longest leg will be connected to ground. If it was a common anode LED, the longest pin will connect to 5 volts. The other 3 pins are red, green and blue. Let's connect this RGB LED to Arduino and see how to make it work. The parts that we are going to need for this project are the following: an Arduino Uno, an RGB LED, 330 ohm resistors, a small breadboard and some wires. You can find links for all the parts in the description of the video below. Let's now connect the parts together. I have connected an RGB LED to a small breadboard. This is the longest pin, this is the red pin, the green and the blue. In order to limit the current that will run through it, we need to use 3 resistors, one for each color pin. If we do not use a resistor or if we use a low value resistor, the LED will be destroyed. We need to use a 330 ohm resistor or higher. The higher the resistor value though, the lower the brightness of the LED, so the ideal resistor value is 330 ohms. Now all we have to do is to connect the first pin of the LED to digital pin 9, the second pin to ground, the third pin to digital pin 10 and the last pin to digital pin 11. In this first example you can use any digital pins you like. Now if we power up Arduino we can see that the LED lights up red, then green and then blue. All we do in the code is to write high to one digital pin of the Arduino and the LED will light up. So if we write high to digital pin 9 which is connected to the first pin of the LED will turn red at the highest brightness. We follow the same procedure for the other 2 pins as well. But if we want to control the brightness of the LED in order to produce more colors, we have to use the PWM functionality of the Arduino. PWM or pulse width modulation is a technique for getting analog results with digital pins. Instead of writing high to the digital pin, with PWM we send a pulse. The more time the signal is high, the brighter the LED appears to the human eye, even though it turns on and off quickly. PWM is attached to certain pins of the Arduino Uno. Those digital pins that support PWM have this symbol next to them. I will prepare a detailed tutorial on PWM soon because it is a very useful feature. We have connected the RGB LED to digital pins 9, 10 and 11 which support PWM, so we can run another example code that produces more colors using the PWM feature. Let's see. As you can see, the LED now produces many colors and with different brightness levels. Let's see how to achieve that in code. I am using a simple function which is named setColor to set the color of the LED. This function takes 3 arguments. The first one is the brightness of the red LED, the second one is the brightness of the green and lastly the brightness of the blue LED. In each case the number will be in the range of 0 to 255, where 0 means off and 255 means maximum brightness. The function then calls analog write command to set the brightness of each LED. So in this line we set the brightness of the red LED to 1, which is the lowest value that we can set, and the other two LEDs are disabled. So the result we get is red color with very low brightness. In this line of code we set the brightness of the red LED to maximum, so we get a very bright red color. If we light up more than one LEDs and set their brightness, we can create any color we like. For example, in this line of code we create the yellow color. You can experiment with the code and create your own colors easily. As always, you can find the code of the examples in the description of the video. As you can see, using an RGB LED with Arduino is very easy. Now we can easily add RGB LEDs to our projects in order to make them much more interesting. I am going to use RGB LEDs a lot in my future projects. I hope that you like this video. If so, please press the like button below. It really helps. Thanks. If this is your first time here, I would love to have you subscribed. In this channel I post videos about do-it-yourself projects every Saturday. I love making things and I believe that anyone can make things, anyone can become a maker. That's why I created this channel, in order to share my knowledge with the community and learn from the community. I hope you will join us. Until next Saturday, watch, learn, build.